In this video, we will choose a database for our microservice. Hi everyone, Yvonne here with another episode of DevWidgets. In this video, we'll choose a database to support the JSON structure that we designed in our previous video. If you've been following along, you'll know that we're building a microservice that returns a list of upcoming events. You can imagine this being something that's shown in either a mobile app, right? All of these events I'm signed up for, or on a website that might advertise all of the events that are up and coming. So when it comes to persistent storing our database, our options on AWS are quite a few actually. At the top you would have, for example, Amazon Aurora. It's a relational database. They have a serverless flavor now. We have Amazon RDS, which has several different types of databases. You could have Aurora, you could have Postgres, you can have MySQL, you can have MariaDB, Oracle, SQL Server, and so on. There's also Redshift for EMR. There's DynamoDB for NoSQL and DocumentDB. So let's get started and look at the JSON structure that we designed. All right, so here is our JSON object. And if you need to understand how we got to this point, feel free to pause the video, go ahead and go back and watch. The link will be up there to be able to get an idea of how we arrived to this JSON object. When choosing a database, it is important to make an informed decision to avoid issues down the road caused by cost, performance, or even worse, some sort of reason that you need to migrate to another database that would require downtime to support your business model. So when coming to this decision to decide, okay, this is the data store that we're going to use to persist our data, there's a couple questions that we need to ask ourselves. So the first one, does our data look relational? And when I look at this, I can kind of break this down into a couple different tables. So for example, you could probably have a table for event. You could have another table that might have your schedule. You could have another table that has location details, right? So for schedule, you could imagine it might have a one-to-many relationship. But when we think about schedule, for example, schedule, I think it can easily be instead contained in this one event and have all the details. If I need to make an update to one instance of that schedule, I still would only have to update this one object. Now location is a little different. If I need to change venue information, there could be n number of events that doesn't really go along with normal form. And actually, as I start talking through this, I actually think, the more I think about it, that location should actually be in its own microservice. There's a lot of components in and of itself that have nothing to do with an event, right? And then instead, here what we would have is location ID, for example. The conclusion is that I don't think this is relational and we can use a NoSQL server. So the next question I think we should ask is, how are we going to query this? So I'll bring here the APIs that we had looked at in the past, in the previous video. And so, for example, the thought was we would call event/v1 events, and that would give us a list of all the eligible events that user could see, for example, right? Or we might query by a specific ID. And then the other one is we might have to do some sort of fancy searching. So when comparing NoSQL versus SQL, and especially DynamoDB is what comes to mind, doing this event/v1 events and having it return all events, that's pretty expensive because that's a scan. So as I look at this, okay, let's put these side by side. How do we make this event be able to be more efficient when querying so that it doesn't have to go and get everything? And so one thought is that actually we should have this concept of an owner or category, right? So instead of getting all the events in our database, we might say, give me all the active events around DevWidgets YouTube videos, for example. And so that would allow us to just get a subset of events. It wouldn't be a full scan on the table. And then we can do more advanced querying and saying, only give me from today on. to be, again, more efficient with that query. And so given those changes, I still kind of think we can support this with a NoSQL server. You know, we looked at this whole scan. We've resolved that. I think by the category, I think that will be sufficient. We'll be able to query by ID. And then when we do searching by events, we'll probably use that same exact category as above. And then we will do additional filtering on the results that get returned. Now, one thought is, you know, how do we get that category? I'm not ready to, you know, do a question mark and add a parameter that says category equals. I think we want to be smarter about that and say, you know, this is the category you are eligible, and you, I mean the client, right? So let's say a given application key, application API key, or something about that authentication. So Yvonne authenticated in the mobile app is only allowed to see events 1 through XYZ, right? And I think that will suffice. So the next thing you kind of want to look at is cost, as I mentioned before. So in terms of cost, you know, let's say that we decided we didn't want to do NoSQL, and let's say that we have a requirement to do IBM's DB2, for example. At that point, we have more costs, right? We have to think about license. You know, we have redundancy, so I'm assuming we'd have to have at least 2 databases in the same region, different region, etc. There's backup. There's also fine-tuning those databases. Do we have the person power to be able to support those type of things? And a lot of times, especially when starting out, I think the answer is we don't, right? And not that we don't and that's a bad thing. I don't think that's a bad thing. But I think it's fair to say, you know, we're starting out, we're not really sure. We can instead start small and take that risk down the road to say, you know what, we're going to have to take an outage so that we can migrate to, you know, an RDS solution or, you know, Aurora serverless, etc. And I think that's okay. So again, given our data, let's take a look at how we might have changed that JSON object. And, you know, I'm going to pull this out of the oven and show it here. And so this is, you imagine what our finalized payload actually would look like, given that we've decided on a NoSQL solution. And so we have status and the enum active, we have the ID, then we have a category. And so for example, here I put an enum of YouTube content. Then we have name, awesome stuff, because yes. And then date and time, that's the same, duration's the same. You can argue that maybe I should change this to instead be like schedule and then it equals a list of date, time, and duration. And as we go and work on this project, if we have to make that change, we'll make that change. But then if you notice here, our location now, because it's still a list, and in that list, it's ID equals XYZ, right? And maybe we decide that there might be other attributes that we need. For right now, I'm gonna leave it as such. And then you could imagine maybe there's owner or some other attribute that distinguishes that this is DevWidgets, for example. And again, because of normalization, because we want to separate concerns, owner could be a separate microservice. Okay, so we talked through the questions that we need to ask ourselves when deciding on a database. We kind of looked at our data and made sure that we are happy with where it's at, and there were no changes or some changes, as you saw, that needed to be made to support a decision. And so that decision is NoSQL. So when we go to AWS, what are our options for NoSQL? So there's DynamoDB, that's a NoSQL option. And then there's DocumentDB, which supports Mongo workloads. So for this project, I'm going to work with DynamoDB. I think it's going to be a pretty robust solution for us. You really just pay for what you're using. It's going to abstract a lot of the heavy lifting for us. All right, so we've made our decision. We have decided on a NoSQL implementation. We have also decided on Amazon's DynamoDB to be able to store our data. So if you have enjoyed this series, please like, share, subscribe. Also, please keep following along in this series. There are longer videos and then there are shorter videos, longer one on top, shorter one down below. Thank you, and most importantly, happy coding.